இது ஓகே தான். இது ரிட்டர்ன் பண்ணியாச்சு இல்லை?
இல்லை, அப்படியே கொஞ்சம் லைட்டாக மட்டும் எக்ஸ்பிளைன் பண்ணுங்க.
Okay students, see the third question. The formula is PV is equal to nRT, that's a formula. Okay, so the unknown quantity is what? Temperature only we have to find out. So therefore we rearrange the formula. T is equal to PV by nR. Pressure is given 2.46 into volume is given 10 ml by number of moles nothing but I told you, number of moles nothing but mass by molar mass 28 by 28. Here number of moles is 1. Then R is 0.082. If you substitute all this, okay, so at last the answer will be nearly 300. Okay, so then here among the four option, which option is nearly 300 means 299.6. So this answer. Understood? Okay, are you following? So remember the formula. What's the formula? This is the formula. Understood? PV is equal to nRT. This is the formula. Okay, now see the next one. Here 200 ml of hydrogen, then 250 ml of nitrogen, each measured at 15 degrees Celsius and 760 millimeter pressure are put together in a 500 ml flask. The final pressure of the mixture at 50 degrees Celsius is dash. That's the question. Okay, so we have two gases. We have the volume is different ml. One is 200 ml, another is 250 ml. We put together in which ml? Which flask? The flask capacity is what? 500 ml. Okay, the two different gases you put together in 500 ml flask. So what will be the final pressure they are asking? That's the question. Okay, so first of all you should find out the pressure produced by hydrogen and pressure produced by nitrogen. We have to find out separately, then add together, then only we are getting the final pressure. Okay, so here so as usual volume is given, then pressure is given. So volume and pressure means, what's the formula we can apply? The statement is what? Boyle's law. Okay, so here for then first of all for hydrogen, as usual formula P1 V1 which is equal to P2 V2. Understood? For hydrogen we are going to find out. See, for hydrogen volume is what? 200 ml. Understood? 200 ml. Okay, its pressure is common for both. The 760 pressure is common for both nitrogen as well as hydrogen. Okay, 760 millimeter of mercury, which is equal to if you put together, our aim is to find out the new pressure. New pressure only, it's unknown quantity. Okay, into these gases are put together in new flask. The new flask volume is what? 500. Okay, you put 500. Okay, so if we simplify, we're getting the pressure for hydrogen. No, so how to simplify? Just cancel this one. Okay, this one 20. I'm going to cancel here also 20. Understood? Okay, then therefore P2 is equal to what? Therefore P2 is equal to 760 into 2 by 5. Understood? So it will be approximately how much? Just multiply. If you multiply means how much we get. Suppose here here this is I put this is one time. Okay, put it here. Okay, so I use 5 tables. This is one time. Okay, this one how many times? 1, 3, nearly, I check it here, 760, no, okay, then 5, okay, here 1 time, here again 2 6, here 5, okay, 25, okay, again remaining 1 0 1 152, understood? 152, 152 into 2 means what? We get nearly 304. Are you following? 304. This is the pressure produced by only hydrogen. Okay. Likewise, we have to find out other one. See, next one is nitrogen. Next one is nitrogen. This is the same formula. P1 V1 which is equal to P2 V2. Understood? Okay. Then as usual here what? The ml only different. Nitrogen is what? Ml is what? Volume is what? Volume 250 into pressure is what? As usual same pressure 760. This is unknown quantity P2. We put it in new flask. No, that flask volume is what? 500. Understood? Okay. That's all. Then cancel as usual. I told you 2 0 cancel. Okay. Then therefore what? Therefore P2 is equal to 760 or not 760, 76 into 25 by 5. Understood? Okay. Now cancel 1 time. Okay. This also 5 times. Okay. Just multiply 760 into 5 means we get what? Nearly 380. Understood? Nearly that 380. Understood? They are asking to find only the final pressure of the mixture. Final pressure means you just add these two. Okay. So final pressure means here both hydrogen and nitrogen together producing how much pressure. So we have to add all this. Okay. That is that the formula method is called Dalton's law of partial pressure. Add all the partial pressure, we get the total pressure. That's called Dalton's law of partial pressure. So you just add the formula I told you, that is total pressure is equal to what? Partial pressure of all this, partial pressure of hydrogen plus partial pressure of nitrogen. Understood? So if you add this, you just, I think you understood everything. These two, if you add means we get what? 684. See this answer. Are you following? Both nitrogen and hydrogen producing how much pressure? That's the question. Understood? Okay. So I put separately. Then if you add means we can get answer is what? Nearly 684. Are you following? Okay. Next one. So this is based on Dalton's law of partial pressure. Understood? So total pressure is equal to sum of all the partial pressure is called total pressure. So that's called Dalton's law of partial pressure. Understood? Next one. See the next one here. Okay. This is based on Gregham's law of diffusion. This is another statement. Okay. So each and every statement I prepared one problem. Understood? So it will be very useful to you. Okay. Equal volume of two gases A and B diffuse through a porous spot in 20 and 10 seconds respectively. If the molar mass of A is 80, the molar mass of B is, we have to find out. Okay. So what's Gregham's law of diffusion means? That's a formula. That is, what's the formula means? Rate of diffusion of A by rate of diffusion of B is equal to square root of molar mass of B by molar mass of A. That's the formula. Why they are all opposite means, the molecular size is increasing means the rate of movement will be decreases. Are you following? Okay. If the molecules are very, very big means it cannot be able to move very fast. Okay. So molecular size increases,